Welcome to another episode of the Bharatvaarta podcast. Today we'll be speaking about the semiconductor shortage, how it has affected over 150 sectors, and where do we go from here. Our guests today are Gaurav Goel and Arun Mampazhy. Gaurav is a micro architect with 2 decades of experience in the semiconductor field. He's worked with the companies like Intel, Synopsys, and is currently working at AMD. Welcome to the podcast, Gaurav. Good to have you here.
Thank you. Thank you, Roshan. It's a pleasure to be here.
Yeah. Arun has a BTech from IIT Madras and an MS from University of Maryland in semiconductor fabrication and has over a decade of industry experience. He's also been keeping a keen eye on semiconductor manufacturing in India and is a frequent contributor to Swarajya magazine. Welcome, Arun.
Thank you, Roshan. Pleasure to be here.
Great. So great to have you guys. As I said earlier, we're trying to surface some tech and policy nuances to this whole debate, right? Let's start with some opening comments from the both of you on what has really happened. We hear of supply chain disruptions and so on, but could you explain this to our audience in a way that they can, easily understand? We can start with Arun and then maybe Gaurav, you can add to that.
Sure.
Yeah, thanks, Roshan. So I'll probably separate it out into two high-level parts. One is India-specific and the global, right? And in terms of the global semiconductor chip shortage, which we've predominantly heard through media in 2021. So as far as the global semiconductor shortage goes, I believe in possibly three main reasons which caused it. One is a bit of less emphasis in terms of the mature node chips, which are predominantly used in automobiles and even in communications. Like 5G and so on. Even a few years back, much before COVID itself, there were reports of the capacity being a little less for, let's say, the 200 millimeter wafer size fabs, which make 90, 130, 180 and above. This is even before COVID, right? And even in by end of 2020, it was quite clear that there has been a capacity crunch in that. So it's possible that some of the leading players overemphasized on the advanced nodes, and there was a bit of a crunch in the mature nodes. So this is reason number one. Second reason is disruptions that were brought in because of COVID. For example, the packaging units in Malaysia, they were shut down during COVID, and a bunch of such disruptions across the globe. And third reason, which a lot of people believe in, is a bit of a hoarding from China. If you look at the amount of chips that China imported from 2018, 2019, they were more in the order of $300 billion worth of chips, of which China needs domestically, it needs about 130, $140 billion. The rest of all are packaged, assembled into products and exported. So more than half of that chip is actually used for exporting. About 35% of the global world's assembly happens in China. Now, in 2020, this number suddenly increased to about $380 billion. So there is a feeling that China saw this coming and had a lot of these chips stockpiled, and that would have that I don't think that is the prime reason, but that probably added to the already existing capacity crunch. So this is probably what happened overall. There could be more reasons, including geopolitical. But as far as India is concerned, I don't think the need for the semiconductor industry to start happening in India is purely driven by the chip shortage. I mean, we can talk more about it later, but the $10 billion package or the few fabs coming up in India is definitely not going to solve the chip shortage all of a sudden, right? For India, it has been a need for decades, which has been not pushed enough, and now we have the push. So for the India perspective, it's not just related to the global semiconductor shortage. It is also about self-sufficiency, and we'll talk about that more later.
Right. So Gaurav, can you explain why this is such a big deal? Because I don't think people really realize, where all these semiconductors, ICs go into, right? I mean, it can be from your, automobiles to your toasters at home. Yeah.
So, Roshan, let me first start by adding a couple of points to what Arun said. So, a lot of people are not aware that semiconductor business is also cyclical in nature. So what it really means is that it typically goes through a 11 to 13-year cycle where there is also at times a inventory glut, which leads to a crash of prices also. So right now we are at the fag end of the cycle where anyways the shortage is building up. The other point is that the nature of the business has changed. when I had joined this industry at that time, a lot more companies used to have an integrated a vendor approach where they would not only design their chips, they would also have some kind of smaller fabrication units. For example, when I was working for companies like Analog Devices, so they used to have their own fabs, also smaller fabs. Now, what is happening is that the cost of running, building, maintaining a fab is so high that most of the people have gone to a model where they want to do a fabless design, and they have outsourced the manufacturing of the chips to companies like TSMC, UMC, etc. Because of this, there are very few players which are there in the fabrication space now. So that is also another reason. Now, when that happens and an event like COVID happens, so the impact on the supply chain is much larger than it would have been had it been more distributed in nature, right?
Right.
Now, coming to your original question about why are we suddenly feeling it? So let me put it this way. So we are more and more getting hooked on to a lot of infotainment, choices in cars, for example, and uh, and even otherwise, if you look around you, if you go and try to add, say, a Bluetooth device to your laptop, you will suddenly realize there are so many devices all around you which are connected in one way or the other. We are surrounded by electronic devices for multiple reasons, for information, entertainment, for other kinds of use cases. So from that perspective, there is no escaping of the fact that you need more and more compute power. And with the emphasis coming on artificial intelligence, machine learning, we are going to see more and more need for the processing power, and hence more and more semiconductor devices.
Right. Yeah, I mean, you find ICs everywhere these days, right? So, Arun, let's take a step back and maybe talk about some of the nuances of manufacturing these semiconductors, right? It's a highly complex process. There are layers and layers involved. Yeah, could you talk through those challenges of manufacturing as well?
Yeah, sure. No doubt, it's a quite challenging industry, both in terms of the kind of capex needed, but probably much more than that, the kind of precision needed, right? Because we are talking about nanometers of critical dimensions. So it's definitely a very complex industry, and moreover the kind of the returns that you might get, it takes a long time, right? So the gestation periods are high, the break even time and so on and so forth is quite high. So this is, as Gaurav also mentioned, that switch between more and more companies going fabless. AMD is one of the examples to it, 2009. In fact, it's interesting. One of the key persons in AMD had in the 90s said, "Real men have fabs." Uh, you know, and later on, AMD itself went fabless in 2009, spinning off Global Foundries as a separate pure play foundry. It
Can I,
started becoming
sorry,
very consistent.
can I just interrupt you there, and maybe if
Sure.
you could explain this in very layman's term to people, right? But what do you mean fab? I mean, I'm an engineer. I have a broad understanding, vague
Okay.
understanding, but
Good question. So let's look at it this way, right? In fact, this is kind of an interview question that I used to ask new graduates, as to, can you just put it in the order of chronological order of what happens, right? So let's say you want a PlayStation, right? What do you do first? You first design. You have an ASIC, right? You have an application specific IC which is very much tuned for that particular application. So you have an architecture, which means that you will have certain kind of speed, you will have certain kind of processor capability, memory. How much of that is quick, DRAM versus an SRAM, a static memory versus a dynamic memory. So all of that, let's say, is the architecture. And now from that you move on to the circuit level, where netlist and so on and so forth comes into play, where you have a circuit level. I'm just putting in as layman terms as possible, a circuit level realization of that. From there, you move on to what is called as a physical design, on how exactly you lay these things out onto a silicon, monolithic silicon wafer, right? So this is where the design company's role more or less ends. and then they, in their language, they tape out this physical design into a fabrication space. Now, in the previous model, when you had the integrated device manufacturers or the IDMs, the design house itself is also has a fab facility. For example, an Intel would design this, and also, they just send it across to the fabrication facility. The first step of the fabrication facility is to convert this physical design. The physical design will probably have all the different layers that are going to be built in the chip. And the first thing that the fab does is to separate this out into different layers. For example, the substrate, or the active area layer, the gate layer, the different diffusion layers, the vias, the metals. So separate it out and also make it into a printable way. In the advanced nodes, you can't just print the design as it is. You need to do something called optical proximity correction and so on. So these are all the things that the foundry or the fab will take care, and they will send that updated design into the mask house. Photo masks are made, which is kind of like your template, right? And once you have one template, you can print multiple of these layers onto the silicon wafers. Typically, a silicon wafer is about these days it's about 300 millimeter in diameter, which is 12 inch, right? There are also 200 millimeters, as I mentioned. So in each of these, predominantly or typically the size of one die, that maximum size you can have is about 25 millimeter by 30 millimeter. So in one wafer, which is probably of this size, you can print multiple of these chips. And by printing, I mean photolithography is a common across all the layers. So you have to do photolithography for your active area, then you have to do photolithography for your, let's say, the gate areas, and later the photo, and each of these layers also have, let's say, either an etching process or a deposition process or a implant process. So you go through all of these layers depending on the technology node. Let's say for typically about a 20 nanometer process node probably will have about 80 different layers, 80 different steps, right? So you print all of this, and you process all of these onto the silicon wafer, onto the, you print multiple of them in one go, of the 300 millimeter wafer, and then dies out each and every processed wafer into individual chips. Then these chips are packaged, and these go into individual ICs, and multiple of these individual ICs will go into a typical electronic product, right? So this is the hope I was not too complex, but at the same time covered it all. So this is what happens. So this is the kind of complexity that is involved here. And yes, it is complex, but as I said, that's probably what prompted the real men have fabs statement. But then as it became more and more complex, and companies like TSMC started offering this contract chip manufacturing model, where you don't worry about how we actually do it, you just give us the physical design and we're going to make it for you. Then companies had the design houses had much less to worry about. All they needed to do was to make sure that they stick to the design rules and so on and so forth. And so that picked up, right? In fact, the pure play foundries actually drove a lot of fabless companies, as Gaurav was also saying, like let's say in kind of the Taiwan model, and that's where we are. You like it or not, that's where we are, and we have to find our path forward based on this new model.
Right.
Just one part which I want to add, so like Arun mentioned, it's a very challenging process, and what is making it harder more and more as we are going. So like Arun mentioned, the wafer size has been constant for several years now, which is 300 mm. Now, how do you maximize your profits? The more number of chips you can print out of it, and you can get better selling price on it, you will gain more profits. Now, when you shrink the size of the transistor, which is the basic building block or the smallest block of a Lego, you can obviously crowd many more chips together on the wafer. Now, to do that, you need to print the mask, as Arun was saying, at so the smallest feature on a transistor is what we refer to as a process node. So you might have heard these terms 5 nanometer, 7 nanometer. So that is basically telling what is the size of the smallest feature. Now, these days we are talking about 5 nanometer and also talking of 3 nanometers. So just to put it in perspective, So when we talk about something like, 5 nanometer or 3 nanometer, we are talking about a feature where you don't even have 50 atoms. So the complexity is very high. So uh, it is not that you cannot manufacture. Yes, you can manufacture, but the amount of manufacturing defects you will end up getting will be so high that your yield will be low. You will not make the amount of profit you need to for it to become economically viable for you. So that is why not everybody wants to be in that field anymore. They want to outsource their troubles to to people like TSMC who have the expertise in photolithography and who have invested the maximum number of PhDs and postdocs for finding out the solution. So one of the things which I do want to mention here is, so the masks that we are talking about, uh, they are so small, the sieve in those masks is so small that we already see quantum effects like diffraction and interference already. We actually already account for it when we manufacture or create those masks. So that is the level of difficulty we are running into. And so this is not going to become easier at all. So Roshan, there is one more point which I want to mention is that ever since I joined the industry, I've only been hearing about the death of the semiconductor industry. And I'm sure Arun has also been hearing the same. So, but the semiconductor industry, especially the fabrication, has been able to make the progress forward. There is this very famous Moore's law, which talks about the number of transistor doubling every 18 months. We are no longer living up to the Moore's law because manufacturing is getting harder and harder. So having said that, the need for higher and higher computation is only going to go up. We will be forced to find solutions. Will we remain silicon oriented industry? I hope so, because otherwise the complexity in manufacturing of the others will be even higher. But so that is where it is. The industry is not going to become easier. So the entry point for India better be now, because it is only going to become harder as we go forward.
Right. So there are complexities on all fronts, right? I mean, Arun mentioned the technical complexity as well, but you mentioned Moore's law. I mean, we're not abiding by those at this point. I think early 2000s or something. I mean, we started flattening, right? And so since then, I mean, people have started using other sort of elements as well, and there are a wide number of elements which go into these ICs as well today. And these elements are sourced from, 30, 40 different places, right? And so the supply chain itself has become so complicated and
yes.
sort of delicate in a way, right? Where a single delay at one particular node may have a ripple effect. It can have a effect across the chain. So yeah, if you could talk about those supply chain constraints, that'll also be helpful.
So the supply chain is hurting us in multiple ways. So the shortage that we are talking about, it is not impacting everyone equally. So the shortage that a premium chip maker like say Apple or AMD or Intel faces is not same as what a small time chip maker faces. That is not the same as what the auto car makers are facing. The reason is that there are multiple assembly lines for different process nodes. The companies like Apple, Intel, AMD, etc., what they are always looking for are the fastest process nodes or the smallest ones, where you get the maximum performance. However, if you look at the automotive industry, they typically want to restrict themselves to very stable process nodes, where the cost of manufacturing per chip is now low enough, and also they cannot tolerate much of errors in that. So where the yield is higher, so which is typically 28 nanometer was a favorite process node for the automakers for a while, but now for manufacturing fabs, they are getting more profits by serving people who want to go down the smaller fabrication nodes, because they also need to get the bang for their investment. So that is why the automakers are feeling, uh, left out because of that. So I'll give a very simple example of how weird the supply chain can be. So I specialize in the high-speed memory interfaces. So when you get a memory card, a typical memory card that you plug it in your desktop, right? So that contains DRAM devices, okay, which are always manufactured on the highest process nodes and everything, right? And they help you get the better performance. So the latest version of the DRAM devices, they got delayed, not because the main chips were in short supply, because on that DIMM slot, there is one tiny chip called SPD, which nobody prioritizes, got delayed because that was not getting, it ended up delaying a lot of products for a lot of companies. So the supply chain, because it is not equal for everyone, is impacting device makers in different ways.
Right. And Arun, just to add to what Gaurav has mentioned, it also means that there's over specialization also, right? And people kind of produce in silos as well. So do you see that changing at all? I mean, given that everything's happened, everything that's happened, do you think that more people will start owning more of the value chain itself?
Yeah, well, as Gaurav was also saying, right? Look at it from the company's point of view. Somebody who has invested millions and billions of dollars in getting specialized equipments, they'd obviously try to push for chips that are made out of that. If you look at the recent statements from the Intel CEO, he is essentially telling the automobile industry that, look, you guys have to move into the advanced nodes, whereas the automobile industry, they are comfortable sitting at the, as Gaurav said, those mature nodes or the nodes which are proven yield, and so on and so forth. So where do you strike a balance? That's one big question. And interestingly, if you look at 2021, there are a lot of new investments coming up in the 28 and the 65 nanometer nodes, 65 for analog, 28 and etc. For automotive. If you look at Italy, if you look at a bunch of examples from Europe and elsewhere, the Japan fab that is going to come up in collaboration with TSMC is probably going to be in the 20s. It is always going to be this push and pull as to when is the right time for a user to switch to a more advanced nodes. Is it really worth? Because for example, in an automobile, the chip and the electronics is not the most important, right? I mean, you have the actual automobile system and the mechanical system, which is much more important. It is the controls and so on that is more important. It is, though, in the coming years with IoT and so on, it is going to, the amount of electronics is going to go up, but still it's a matter of when do you make that switch, which obviously will have to be,
and
yeah,
with
which obviously will have to be
electric
charged on the
vehicles as
customer,
well.
right?
Yeah.
Sorry?
And with electric vehicles as well, right? Which is, I
Yeah,
mean,
the
without the
EVs is,
usual,
that's another, that opens up another big opportunity there itself. So with all of these now, is the supply chain going to get more diversified versus more concentrated in a few players in a few countries? I think it's going to be a mix and match. There are a few things which are going to be concentrated. For example, right now TSMC and Samsung are the only ones which can make the 7 nanometer and the 5 nanometer chips. I mean, Intel of course claims that their 10 nanometer is as good as 7 nanometer, but you're still already shrunken into two players or 2.5 players, as some say. In terms of the equipment that is needed, the photolithography equipment that is needed, the UV based lithography stepper, ASML is the only one which is making it right now, though probably in fact, it has come to such a stage that a lot of people tend to believe that ASML overall is the only equipment manufacturer for semiconductors, which is not true. It is one out of the big, there are big five ones, and there are a bunch of smaller ones also. But because this one particular lithography tool is made only by ASML, the world has come to believe that everything is stuck on them. So it's not completely as it is made out as to completely stuck with a limited number of people. Certain aspects of it are stuck with a very limited number of players, or even sometimes a monopoly or a duopoly, whereas there are still a lot of aspects of it which are spread across, and the important thing is to make use of all of that. In fact, I don't think any country can achieve 100% self-sufficiency in the supply chain. It is about how much more you can be self-sufficient. even our Atmanirbhar efforts in this direction should be to be more and more self-sufficient, reduce our dependency on imports and so on. It is never going to be for 100% on our own.
All right, I think we've given enough background to people on the complexity and the nuances of manufacturing semiconductors and how they're applicable. I think we should talk about, how do we go from here? How do we build these core competencies as a nation? So Gaurav, maybe you could start and then Arun can add.
Yeah. So let me first talk about, we went through several failed starts on this front. Okay. So of course, the government started their own fab in early 80s. Okay. SCL, Semiconductor Complex Limited. It wasn't really a great success. Contrary to some belief on social media, SCL was never one of the key players at the world level. Okay. And unfortunately, it did not go from strength to strength, unlike DRDO or ISRO. The big, their most advanced process node is still 180 nanometer, which is nowhere close to being competitive in the world. So after that, there were a couple of failed attempts. So the reason why the first set of initiatives did not work out was because government was trying to just focus on only one aspect, which is the capex. So the capex for the fabs is very high, no doubt about that. So they were trying to bring in some, big investors. They were trying to, if I remember correctly, in around 2013 time frame, they were trying to build two fabs, okay, HSMC, and there was another one, I think, with the JP group. And none of the efforts really bore fruit because none of the main players had any experience with chip manufacturing. They were hoping that somebody would come on board. And I think for a very brief amount of time, I think Global Foundries did show a little bit of interest in one of them, but it never really panned out. So that is why, so just solving the capex issue is not going to be enough. Unlike other industries, this is a highly specialized, highly niche industry. You need to get a jump start. You need to have well-established players. So that is why I think what we are currently trying to do in this round, where we are trying to invite the biggies of the fabrication world to India by offering them the stops. So for example, the other thing is, in this industry, you cannot succeed as an island. You need to develop an entire ecosystem, which there was no such focus in all the previous initiatives. In the current initiative that has been announced by the government, they are trying to focus on the entire supply chain. They are talking about setting up the test assembly units. They are talking about incentivizing setting up of the display fabs, of the regular semiconductor fabs. They are talking about, even I was very surprised and very pleasantly surprised to see that there were some incentives for even fabless design work. They want to promote domestic companies to take up that work. So that is why at this time, this is a very good, it's a very good set of SOPs that they are offering. But at the same time, they need to work very closely with at least a couple of the well-established fabs which exist in the world. I don't want to take their names, not to jinx it. So I'm just hoping that one of them is sufficiently, persuaded to set up the shop here.
Right. So, Arun, just to add to what Gaurav has said, right? I mean, I call it a core competency because I think it's not just an economic issue, it's also a national security issue as well, right? So, what can we learn from other countries? The US, China, Korea, and all of those. Because, compared to our $10 billion, I mean, they have invested hundreds of billions of dollars, right? So, what can we learn from them? And how do we get a head start, maybe?
Yeah, definitely. So, first of all, I don't think there's no one country from which we can exactly model it upon, and neither is, or in other words, all of these countries, what they are trying, there are probably elements for us to learn. Let's quickly go through some of those. I don't intend to cover in too much detail. Korea, it's a similar giant as Taiwan in terms of, especially the kind of some of the companies that it has. Samsung, for example, it's a giant in its own way, right? It's, if you take the overall electronics, consumer market, they are second next to Apple. If you take the chip the semiconductor sales revenue, they are second only to Intel. They were second, now they are first. They have overtaken Intel. And if you take the foundry, they're again second only to TSMC. So they're well established in certain areas. It's not across the board. Samsung is much more, in terms of memory and so on. So what Korea might be trying to do, I'm not too sure if we have much of that to learn in terms of the numbers, in terms of the billions that both Samsung is planning to invest, as well as the government is planning to incentivize. They are huge, but let them do it. The only thing we could, as India, we could try is maybe among the companies that we are trying to reach out, Samsung or a few other players in Korea could be part of, in terms of proactively inviting them to set up companies in India. As far as US goes, let's not completely be taken back by the $52 billion that has been in the news. If you read the document, it has its own nuances. In fact, there is a cap of $3 billion per fab that they're going to incentivize. Plus, a lot of that is split between NSF and establishing a technology center in US and so on and so forth. It's still not clear. It's still evolving exactly. In fact, TSMC in Arizona has already started building its fab. I don't think they really waited for the clarity on how much the US government is going to incentivize. Intel is still looking to get a lot of it out of the US government. The point here is that, again, there are elements we could learn, especially how the US has handled the defense aspect of it. They have something called a trusted foundry model, where they are commercial fabs which make the chips for the defense of the DoD, Department of Defense, US also, but they have enough checks and balances in place to make sure that these chips are not compromised. Again, I don't want to get into the details of it right now, but there is a program called Trusted Foundry, as well as there's a recent program called RAMC. The C there stands for commercial. In other words, when Gaurav was talking about the SCL and the DRDO and so on and so forth, why these models do not work, part of the reason is because, again, it's not really the government's business to run fabs, right? Except for very, very low volume critical application chips that can be made out of some of these fabs. Ideally, what we need are commercial fabs, because we need volumes to get to the yield that we need to have reliability on these chips, and then work out a program by which the government can have its own dedicated line of supply, as well as reliability in terms of what it needs for its strategic application. So these are the lessons that we can learn from the US. In terms of China, in fact, whether knowingly or unknowingly, I think the government of India is kind of going down the path to what China has been trying to do for the last few years. There is a recent report in the Semiconductor Industry Association's website, semiconductors.org, on how China has increased. And that's kind of, as Gaurav was also pointing out, trying to create the entire ecosystem. There are a lot of fabulous design houses that have come up in China over the last couple of years. In fact, fabless plus assembly units and so on and so forth, plus core fabs. And within the fabs, you have a diversification in terms of compound semiconductor fabs, some of which, for example, silicon carbide and gallium nitride could typically also add on to the EV market. And then, of course, not just the advanced node fabs, but mature node fabs, both in the analog world as well as in the mixed signal and digital world. So they have diversified it, and that's probably the model which India is also trying to take forward. There has been some flaws in China. There has been a couple of companies which have gone bust. In fact, some say up to 6 companies have gone bust trying to do the some of the advanced stuff and so on and so forth. So we have to be cognizant of all of that. But I think the right framework has already been developed. The policy that has come out, the $10 billion incentive policy, it's not just the policy, it's not just the money per se, right? The intent there in terms of creating this entire ecosystem is definitely right. It's now we've entered the phase of execution. Couple of things that I would just request the government to be careful about is that while we do wait for some of these big ones to come and set shop, let's also not wait on it forever, right? There are for example, there are players within the top 10 itself, but not as famous as a TSMC or a Samsung, who have been interested for years now. And it's important for the government to make sure that some of these start taking off, right? Nothing succeeds like success. So once you start seeing that, yes, there are some of these, not really a $10 billion fab, but maybe a $3 or a $4 billion fab already doing groundbreaking and coming up, that's probably when the world will sit up and say, oh yeah, India is really serious about it and things are actually rolling. So to break that 10-year or 15-year or 20-year of belief that only policies exist in India, not really factories, we need to have some of these take off immediately, I would say in the next 6 months, and then I think more and more will start coming.
Right.
Gaurav, anything else you would like to add from a policy perspective? Because
yes. So Roshan, there is so one of the key things that adds key value in this entire supply chain is test assembly units. Currently, it is mostly the Southeast Asian countries which dominate there. Okay, so you have Philippines, Vietnam, Malaysia, which dominate this space. Now, this is a space which does not need as much specialized knowledge as is needed for the manufacturing of the actual chips. However, this is a very key component, and it typically it creates a lot of jobs in that space. And this is where I see, I'll say, hope from what the government has announced, because they have covered this space. And in fact, very close to government's announcement, there were also announcements by Tata Group and Vedanta, because they also have indicated that they would be interested in setting up the test assembly units in India. Because like Arun said, we cannot be a nation which only has a policy but no real semiconductor industry. So for that, even if we can get started with something, I'll call it the lowest hanging fruit in terms of this entire value chain. If we can get started even with that, we will eventually be able to convince other folks that yes, labor-intensive, capital-intensive industries of this magnitude, of this complexity can be set up in India.
Right. Yeah, I mean, that was going to be my next question, which is how do we make it financially lucrative for people to invest in this, right? Because as I understand, the payback is over, many years, if not decades, right? And you can't have the usual VC kind of activity that you see in, normal startup, software technology kinds, right? So how do we make it lucrative for potential investors to look at this industry and actually like put in their monies?
Mm-hmm. So if you see, currently we import practically every single chip that comes to our country, out of which there is a lion's share that China has right now. I think around 30-40% comes from China. So there is a significant domestic market. Now, that may not be there for extremely advanced chips. And I think that is not what we should be targeting either. I think we should be targeting the most commonly used chips, which could be right from what goes into the components of a simple LED device, light, to the display panels, to chips used in the industrial processes. I think that is what we should be targeting first. And for that to happen, the market already exists in India for that. So in fact, if you see, there has been a lot of assembly units which are there for mobile phones right now for the LCD manufacturers. So what I foresee is that the display fabs are most likely to set up their shop in India first than the actual the rest of the semiconductor fabs, because that is where they will be at, because there is a significant industry, a significant market that already exists for them. So I think that is where they will see value in it.
Right. Arun, would you like to add to that?
Yeah, I think I'll probably take that question in two ways, right? So in terms of players like Tata or Vedanta, for example, first of all, to the best of my knowledge, Tata have actually not officially said exactly what they're getting into. It's been in the news that a $300 million plan for what is called as an OSAT, right? The outsourced semiconductor assembly and testing. And they already, by the way, so while we talk about the $10 billion incentive that has recently been announced, I think we should also kind of rewind back a couple of years in terms of the bigger picture of the PLI that was announced 2 years back, or 2020, which also covered the mobile assembly as well as hardware like laptop assembly and so on and so forth. And Tatas are already known to have started some program in Hosur, which is probably for that. So I think they are slowly getting into that space one by one. They have an MTech program launched in collaboration with Shastra University and some Taiwan universities for design as well as a little bit of manufacturing exposure. So definitely, I think Tatas are planning it. What exactly, how exactly, when exactly, we don't know. Vedanta, they have kind of openly said what they want to do in terms of display fabs. They what they call as an integrated display, which probably means both LED and LCD. Each unit probably costing about $4 or $5 billion. But beyond that, their semiconductor pitch has so far not been clear, and the policy is quite clear in terms of who can apply. You need to have either a partner which is already experienced in running a fab, or you need to have a license from an already existing fab. So not anybody and everybody can apply unless you really have a license from one of the players. So we'll have to wait and see. But I don't think these are the only players. There are a few other semiconductor fabs through their Indian business partners who have also expressed interest and who've been trying, and they, I'm pretty positive they're going to apply, including venture capitalists. So let's now come to that aspect of it, right? So I don't think it's the because the spectrum or the breadth of what has been offered by the government of India is it's quite vast. I don't think there is. I mean, in other words, I do think there is scope for VCs or even sort of individual or small group investors who probably have a few hundreds of crores or something like that. It's just a matter of you need to know exactly which of these segments offers what, right? So say, for example, to set up a design company, either as a fresh new startup or adding on additional funding of an already existing startup which wants to go a little big. I think a few, even tens of crores or at least hundreds of crores is probably definitely going to be good enough. If you have a few thousands of crores, you can definitely look at the OSAT incentives that have been offered, as well as maybe some of the compound semiconductor aspects, though it might need not just 1,000, maybe like more like a 5,000 to 10,000. And then of course, if you are a big player, if you're willing to invest more than 10,000 in the 20,000 range, then the first thing that you should probably be doing is to get a tech partner, right? Or a partner who is willing to do a technology transfer. In other words, it could be a collaborative effort. It could be, let's say, for example, a TSMC plus a Tata. I'm just taking an example, right? A TSMC plus a Tata joint fab happening in India, or it could be Tata owned fab, but the technology being transferred from TSMC if they're willing to do that. So there are different of these models. And it's a matter of knowing what you're getting into. The key aspect of course is that you have to be patient, right? This is not an industry which can give you quick returns. In a country where probably people are crazy about quick IPOs and being a unicorn in a few years, you have to be a little bit more patient in this industry, and also know the little bit of nitty-gritty. You don't have to go into the depth of knowledge of what it is all about, but at least know the market and know what you're getting into.
Right.
So you mentioned mobile phones, right? And we've done phenomenally well. I think we're the largest, second largest manufacturer on mobile phones, for example, right? So I think one of the key advantages that we will have is also the talent that we have, right? Now I know that there won't be too many design engineers or core engineers as such, right? I mean, but still, even by sheer odds, considering how many engineers we graduate every year, I think we'll have a sizable number of engineers, right? I mean, what do you think, Gaurav?
So Roshan, so here is some interesting news for you. So we have actually already become a very important geographical site as far as the chip design happens. All the well-known chip design firms do have an R&D center in India today. I think since Facebook and Facebook, actually they also recently started. So pretty much everyone I know, whether a big name or a small name, they all have an R&D center in India. Okay, so as far as the design side is concerned, I think in the last 30 years or so, Arun can correct me. So, so that is when this entire value chain has already stabilized. And so another core component of the chip site is called verification. And we have and something known as mask design. In these three things together, we already have a nice, large enough talent pool. And all the companies all over the world are currently using I'll go to the extent of saying that any major chip product that gets announced in the world right now has at least a transistor which has been designed by an Indian. So whether that Indian is sitting in India or whether that Indian is sitting in Silicon Valley, most likely in India, actually. So from that side, we already have a nice enough talent, but I think we will still have a talent crunch. And the reason is that the kind of talent that is needed for manufacturing or talent for test and assembly is a very different kind of talent. We do not have sufficient device physics postdocs in India, or that can be directly hired for the fabs. So I think another important things that the government needs to do is that beyond the tax incentives, they also need to make it lucrative for the expats with the right set of talent to come back to India. There are a lot of Indians in this space who do have the right skill set. Unfortunately, they are not sitting in India. We need to be able to attract them back. And secondly, we need to be able to have meaningful programs between industry and academia so that we can create a future pipeline. I think there we are going to struggle. So in terms of designers and all, I think you don't have to struggle. I mean, Bangalore and Hyderabad and a few other places, we have significant chip designers. So, but when you set up a fab, you don't need just the device physics people, you also need chemical engineers, you need production engineers. We need to have real high quality engineers who have actually worked in plants. Unfortunately, in India, irrespective of what stream you get into, you end up coding at the end of 4 years. So I think that is what we need to rectify. We need to tie up with universities abroad, with companies abroad, so that we can create that talent pool, and in the short term, get those people with the right skill set back to India.
Right. I knew when you started out that somehow it would make its way to criticism of software engineers, right? The industry where I work, right? Yeah. So we've discussed plenty of these nuances, but where do we go from here, Arun? So if you look at where we are right now, Jan of 2021, how do you see this playing out? What is the future like?
Yeah, Jan of 2022. So
2022.
Right, time flies. So yeah, it's I think it's going to be a very exciting journey. And by the way, just to set that kind of notion aside, even the fab needs software engineers, right? You have you have automation, high level of automation that are needed to run these fabs. So both in terms of each individual equipment needing a software and a software support for that, plus how these equipments are connected together and how the line runs through automated robotics that loads these wafers and so on. So software automation, AI, ML, it's kind of interesting. You make chips to do AI or ML, and then you use that ML and AI back into the fab to make your fabs more productive. So it's definitely needed. And yes, so let me put it this way. I'll probably see there are three major challenges ahead. One and the most important is, I would still say, get started, right? Until the government of India actually goes a little proactive in terms of facilitating at least, as Gaurav said, a few OSAT units or an analog fab or a compound semiconductor fab in the next 6 months or 8 months, because right now the iron is hot. Hit it when it's hot, and prove yourself that we are capable of doing it. We are capable of providing the infrastructure and providing the necessary incentives to get it going. So this is the most important challenge, I would say, or the immediate short-term challenge. Second would be, how do you coordinate this entire ecosystem as it grows? For example, the government of India wants about 100 startups to come up in design. Startups or existing companies, increasing their productivity and so on. 100 companies will be offered the design-linked incentives. And these, some of them, government wants to grow to the size of, let's say, a Qualcomm, or at least 1/4 of a Qualcomm or a MediaTek. Now, as these come up, you will need to actually make the chips at the design. And because a fab is not going to come up in India or not going to get into a production stage for the next 3 or maybe 5 years, for now they will have to depend on an external fab. So now, how do you eventually make sure that these design houses also channel their orders into a fab that is going to come up in India? And likewise, the various other coordination with academia, and so on and so forth. So this is going to be the second challenge, which I think is going to be a bit more medium term than the first one that I mentioned. And final one, I would say, is the talent part of it, which I feel is a little bit more longer term. As Gaurav said, design manpower is already there. It's a matter of how do you kind of make sure that instead of working for an MNC, which is fine, which is good, right? India gets a lot of there's a lot of use of that as well. But how do you make some of them to go into startups or more India centric design houses, which kind of makes for India, right, or make in India? But apart from that, also the bigger manpower which are needed for assembly units and fabs and so on and so forth. The positive is that there is enough time at the hand of government, probably 3 years, 4 years, by the time these actually come up and become productive. But there's also this challenge that this is also a kind of manpower that will be globally lacking in the next few years. So there is also this challenge of the more the government of India facilitates this training. A lot of them are also going to see this. By them I mean the engineers who's going to take this training are also going to see this as an opportunity to go abroad, which is fine, right? It is natural to happen. It will be there. So the kind of quote unquote attrition that is now being seen in software industry in the wake of working from home and so on and so forth, 5 years, 7 years down the line is probably going to happen in terms of the semiconductor industry also, because government has put in a lot of effort to bring up this manpower and the talent, and now you will see them slowly kind of being taken away by other countries. So it's natural, as I said. It's a long term challenge that we have to be ready about, and it in fact it's a problem of plenty is always welcome. So let's go overboard, make sure that there is more than enough talent that is needed for just India, just like make in India and for the world. Let's also train in India for the world. Nothing wrong in it, right? And they already exist also, as Gaurav said. Definitely bringing back some of the NRIs who are in this field, and it's tremendous, right? Any discovery, any a lot of patents, a lot of actual. I mean, there are CEOs who are of Indian origin. There are senior directors, VPs across the foundry industry, which are Indians. And if even 10% of them can come back to India, or even 5%, I think it'll make a huge difference. And the government has to just play the role of a facilitator here. And I think that is where the India Semiconductor Mission, as far as I know, is headed there. It is probably going to be a standalone body with its own, with its own empowerment, probably headed by a few people from the industry itself who are willing to come back to India and drive this effort. And they are going to set the base for how we're going to move forward. So exciting journey ahead is what I would say. There definitely challenges, but obviously, you have to have challenges to be successful as well.
Right. Just curious, what are some of the non-government bodies that are, in the fray as well? I mean, that are helping out the situation. Do you have like Semiconductor Association of India or something of that sort?
Well, see, there are different associations, like for example, the IESA is there, and I forget the exact name. So let's look at it quickly in two ways, right? One, there are the semiconductor based associations, but right now, for example, the IESA is probably much more into the members are much more design background, which is natural because that is what is there in India. There are forget the name of the other association, but there are some which are a bit more familiar with the assembly aspects of things also. So they are probably driving that. But let's not look at only the semiconductor based associations, right? There are also industry bodies like CII and SIAM, for example, the automotive association. So they play a very key role here because ultimately market is one thing. India needs a lot of chips is one thing, but how do you make sure that the fabs that are going to come up in India are the ones who actually get these orders? And that is where associations where, let's say, a Maruti or a Tata Motors or a Mahindra is part of also play a key role, because they also right now, not just after 4 years when a fab comes up in India, but right now they have to start studying what are the aspects which can be indigenized when these ecosystem comes up in India. What are the equipments and what are the components and the parts which we can buy within India itself rather than export by the time this ecosystem comes up. And to the extent I know, that effort has already started. There are some of these automotive makers that are based in India, and not just automotive makers, hopefully across the spectrum of industries. There are already efforts in terms of looking at what can be indigenized. So they definitely play a very crucial role. It's definitely not, this is not going to happen just by government effort. Government can at best be only a facilitator. There is going to be individual industries, industry bodies, individuals as talent pool, academics, everything has to drive this, no doubt about it.
Right. Final comments from you, Gaurav, and then we can close.
Yeah. So I think there are only two things which I felt should have been emphasized on in the government policy. So the first one is that unlike the software design where you code something, you compile it and you're ready, the code, the design that we code, it goes through a series of tools. It gets converted into various formats till it can be manufactured using photolithography. So those EDA companies, those tool makers also need to be incentivized so that they can create those tools and libraries specific to our fabs. And if you look at the TSMC model, they have a great ecosystem. They have nice tie-ups with all these EDA tool vendors, and they also have tie-ups with a lot of IP companies. So let me explain that thing. So any chip that is manufactured today, nobody manufactures it completely. So there are parts of the chips which people have expertise, which they design, and they come as a ready-made Lego block and you plug it into your chip. Now, some of these are dependent on the fab that is on which it will be manufactured. So we need to also incentivize the creation of that library or that portfolio of the IP designs, so that if somebody does want to, there is a fabless company that does actually want to place an order with a fab based in India, they need to have this entire ecosystem in place. So I think that's the only request I have to the government, is that they should look into incentivizing that. I think a part of the way they are looking at it is that they are trying to incentivize design, and they're hoping that that will take care. In my opinion, that is not enough. They need to have more specific requirements in terms of creating that library of ready IPs.
So this was a fascinating conversation. Believe me, I mean, I didn't know much before we started, and just got to know plenty of different facets of this very complicated issue. Thank you so much, Arun. Thank you, Gaurav, for joining us and lending us all of these insights. And we look forward to doing an update sometime.
Sure, definitely.
Yeah, thanks a lot, Roshan. And I should also add, media also plays a very important role in this whole effort. Unfortunately or not, there has been way too many negativities floating around in the media. It's a non-workable project. India can never do it. We don't have the water. We don't have this, that. So to correct all of those perceptions, it is challenging, no doubt about it. But India can definitely do it. So media also plays a role in this, and let's hope together we make it.
Right. That's a very optimistic note to end on. Thank you again, Gaurav and Arun. Thank you.
Yeah.
Thank you. Have a good night.
Thank you for tuning in to this episode of the Bharatvaarta podcast. If you want to see more content like this, then don't forget to subscribe to our channel. We started Bharatvaarta to facilitate long-form discussions on politics, policy, and culture. We don't necessarily endorse anything that was said in this episode. If you wish to offer us feedback, do reach out to us on social media. We are at Bharatvaarta on Facebook, Twitter, and Instagram. You could also get in touch with us on our website, www.bharatvaarta.in. The links are in the description below. Until next time, stay safe, take care, and Jai Hind.